A deep Atlantic low position to the west of Ireland on the EBA becomes the dominant force, shaping the weather across much of Europe. As the pressure at the center of this system drops, the surrounding atmosphere reacts with increasing intensity. Air rushes in, spiraling upward, strengthening the circulation, and tightening the isobars that frame the storm. These closely packed isobars are visual markers of powerful winds, the kind that sweep across open waters and push into coastlines with force. The system gathers moisture from the vast Atlantic, drawing it into long, sweeping rain bands that rotate around the center of the low, ensuring repeated episodes of rainfall rather than a single passing shower. The location of this low to the west of Ireland is crucial. Positioned over open ocean, it has access to an endless supply of moisture and room to deepen further as it interacts with contrasting air masses. Moisture-rich air is pulled northward into the storm's warm sector, while cooler air wraps in from the west and northwest, creating areas of atmospheric instability. This imbalance enhances cloud formation and sustains persistent rainfall. The circulation extends far beyond its center, influencing weather patterns across Ireland, the United Kingdom, and eventually much of Western and Central Europe. As the low approaches, Ireland and the UK find themselves directly exposed to increasing wind speeds and waves of heavy rain that repeatedly sweep across the region. Coastlines face gusty conditions, and inland areas become vulnerable to saturated soils and rising water levels. The sheer size and depth of the system ensure that its influence is widespread, not localized, shaping the atmosphere over thousands of kilometers and setting the stage for an extended period of turbulent, energetic weather. Ireland, the United Kingdom, and Western Scotland stand directly in the path of the storm's most active zone, experiencing the full force of the system as it pushes waves of moisture inland. The circulation around the low-pressure center sends repeated bands of rain sweeping across these regions, often arriving one after another with very little time for the ground or drainage systems to recover. Each band brings its own mix of persistent rainfall, sharp downpour, and gusty winds that strengthen as the pressure gradient tightens. Coastal areas become the first to feel these effects, especially along the Atlantic-facing shores where the winds accelerate and waves build in heightened energy, making exposed cliffs and harbors particularly vulnerable. The combination of strong winds and sustained rainfall creates an environment where flooding risks rise quickly. As the atmosphere pulls moisture from the Atlantic and wraps it around the low, regions such as Western Scotland and Western Ireland find themselves under some of the heaviest and most consistent precipitation. These areas often deal with topography that enhances rainfall, with hills and mountains squeezing additional moisture from the clouds and intensifying the totals. Rivers swell, streams run faster, and low-lying areas begin to pool with water as the relentless feed of moisture continues. Despite the storm's intensity, temperatures in the warm sector remain surprisingly mild, creating a contrast between the gusty, turbulent conditions and the softer air masses being pulled northward. This mild, however, does not stabilize the atmosphere. Instead, it deepens the instability, making the air more prone to sudden bursts of rain, shifting wind, and rapidly evolving cloud formations. The overall setup ensures that Ireland, the UK, and especially the western coastal regions remain under continuous pressure, experiencing some of the most impactful weather during this period, shaped by a system capable of producing both widespread disruption and long-lasting rainfall episodes. Northern France, Belgium, the Netherlands, and Denmark sit along the advancing edge of the Atlantic system, experiencing a transition from calm to unsettled as the frontal boundaries move inland. In northern France, the first signs appear early, with cloud layers thickening and building throughout the morning. This gradual increase in cloud cover signals the arrival of moist air being pushed toward the continent by the strengthening Atlantic low. As the day progresses, the frontal system extends its reach, spreading steady and persistent rain eastward. The rain begins gently but soon becomes more established, covering wider areas as the front deepens and matures. Farther north, Belgium and the Netherlands lie along a tightening pressure gradient created by the interaction between the deep Atlantic low to the west and relatively higher pressure to the east. This contrast intensifies winds, producing brisk, sometimes gusty conditions even before the heaviest rain arrives. The atmosphere takes on a damp, unsettled feel, with intermittent rain and rapidly shifting cloud cover. Streets become slick as showers pass through repeatedly, and the wind brings a persistent chill despite temperatures that may not be particularly cold. The unsettled nature of the day means there are few prolonged breaks, with the weather evolving constantly. Denmark also falls under this tightening gradient, where the wind profile becomes more pronounced due to its exposure to both the North Sea and the Baltic. Rain arrives at intervals, often carried swiftly on the strengthening breeze. The cloud cover remains thick and widespread, leaving very little room for sunlight to break through. Although the rainfall may not be as heavy as what occurs farther west, the continuous stream of moisture and the persistent wind together create a feeling of instability and restlessness in the atmosphere. The overall pattern across these regions reflects the steady eastward push of the Atlantic system, bringing moisture, wind, and a sustained period of unsettled weather. Italy and the Balkans come under the influence of a powerful Mediterranean-driven pattern, where developing low pressure taps into warm, moisture-rich air streaming across the sea. As this low forms and strengthens, it begins to pull vast amounts of humidity upward into the atmosphere, creating an ideal setup for widespread and sometimes extreme rainfall. Central and southern Italy are among the first to feel the effects. Moisture is funneled into the peninsula, colliding with its rugged terrain. The Apennine Mountains act as natural barriers, forcing air to rise and cool, which dramatically enhances rainfall totals. What might begin as steady rain can quickly intensify into heavy downpours, thunderstorms, and sudden bursts of extreme precipitation that overwhelm drainage systems and dry riverbeds. This combination of ocean moisture and mountainous terrain significantly increases the risk of flash flooding, rapid runoff, and storm development. The influence of this Mediterranean system spreads eastward into the Balkans, creating one of the most active and intense rainfall zones in the entire region. Greece, Albania, and North Macedonia find themselves directly beneath the moist conveyor belt feeding into the system. Here, the rainfall is not only heavy but also prolonged. Thunderstorms repeatedly regenerate as warm sea air flows inland and interacts with cooler continental air. Valleys collect runoff, mountain slopes accelerate water flow, and urban areas struggle under the weight of continuous rainfall. River levels rise steadily, saturated soils weaken, and landslide risks grow with every passing hour. This connection between the Italian low and the broader Balkan weather pattern creates a corridor of extreme precipitation, where atmospheric energy remains high and conditions stay volatile. The geography of the region amplifies the impact, turning already heavy rain into potentially dangerous episodes of flooding, storm activity, and rapid hydrological changes that persist through the period, making Italy and the Balkans some of the hardest hit areas. Scandinavia experiences a very different side of the broader European weather pattern, shaped by its geography, colder air masses, and proximity to the Atlantic's moisture supply. Norway faces the most dramatic effects, especially along its western coastline, where moist Atlantic air is forced upward by steep mountain ranges. This lifting process produces continuous and often intense rainfall that persists for hours or even days. The same mechanism causes snow to develop at higher elevations and across northern regions, where temperatures are low enough, creating a mix of heavy rain and accumulating snow within relatively short distances. Fjords, valleys, and steep slopes in Norway amplify the impacts, increasing the risk of rising rivers, snow loading, and localized flooding. Sweden's experience differs because much of the Atlantic energy loses strength as it crosses the Norwegian mountains. What reaches Sweden often becomes mixed precipitation, shifting between rain, sleet, and snow depending on the time of day, elevation, and the interaction with passing fronts. The colder continental air over Sweden creates a more unstable profile where sudden bursts of winter-like conditions can appear briefly before turning back to rain. This back and forth trend keeps the atmosphere unsettled, making travel and daily life more challenging as conditions change rapidly. Finland sits even deeper within colder air, and the meeting point between moist Atlantic influence and Arctic. Derived air generates a blend of wintry precipitation. Snow becomes more common here, especially in central and northern areas, while southern zones may see alternating sleet and cold rain. The frequent arrival of passing systems prevents the weather from stabilizing, leaving the country under a shifting pattern that reflects both oceanic and Arctic influences. In contrast, Spain and Portugal lie on the edge of nearby high pressure, experiencing calmer and more stable weather. Most of the Iberian Peninsula remains dry, with only the northwest catching scattered showers. The rest of the region benefits from clearer skies, milder conditions, and a relative calm that stands in stark comparison to the storm-driven patterns unfolding across northern and central Europe. Between the 18th and 20th, several regions across Europe face one of the most significant multi-day rainfall events of the month, shaped by the interaction of a deep Atlantic low and a moisture-rich Mediterranean system. As these two major sources of atmospheric energy unfold at the same time, their combined effects lead to widespread, intense, and persistent precipitation. The Atlantic low drives long-lasting rain bands into western and northern Europe, while the Mediterranean low fuels powerful storms and heavy rainfall across southern and southeastern regions. Because these systems evolve slowly and continuously feed moisture into the same areas, rainfall accumulates rapidly over multiple days, increasing the risk of flooding, saturated ground, and unstable terrain. Norway's western slopes experience some of the highest totals as moisture-laden Atlantic air is lifted over the mountains. This orographic effect repeatedly forces clouds to release heavy rainfall, and at higher elevations, the same moisture turns to dense, accumulating snow. The steep terrain of western Norway accelerates runoff, raising river levels and creating potential hazards in valleys and fjords. In the western Balkans and Greece, The interaction of warm Mediterranean moisture with cooler continental air forms a persistent corridor of extreme rainfall. The presence of mountains across Albania, Montenegro, and northern Greece intensifies precipitation, producing torrents that continue day and night with soil already saturated. These regions face a heightened risk of flash floods, river overflow, and landslides. Southern Italy also sees significant rainfall, with coastal and upland regions receiving repeated heavy bursts as the Mediterranean low rotates moisture over the peninsula. Parts of the UK, especially western Scotland and western Ireland, endure prolonged rain bands circulating around the Atlantic low, creating conditions ripe for localized flooding and travel disruption. Together, these overlapping systems create a widespread multi-day episode where rainfall intensity and duration reach dangerous levels, leaving several European regions vulnerable to hydrological and geological impacts. As we reflect on this period of intense and widespread weather, it becomes clear just how interconnected and powerful Europe's atmospheric systems can be. From the deep Atlantic, low-swirling west of Ireland to the moisture-laden Mediterranean lows shaping southern Europe, the continent experiences a vivid demonstration of nature's force. Regions across the British Isles, the Balkans, southern Italy, Scandinavia, and beyond face not only persistent rain, gusty winds, and mountain snow, but also the very real challenges of flooding, landslides, and rapidly changing conditions. The complex dance between oceanic energy, mountainous terrain, and shifting air masses reminds us of both the beauty and the unpredictability inherent in our climate. Observing, understanding, and respecting these patterns allows us to prepare, adapt, and respond effectively to the environment around us. As we close, I want to extend my best wishes to everyone navigating these conditions. May you stay safe, stay informed, and find calm in the midst of the storm. Remember to look after one another and approach the weather with both caution and respect, knowing that preparation and awareness are our strongest tools. Good luck in the days ahead, and thank you for taking the time to understand and follow this detailed forecast. Stay safe, stay vigilant, and may clear skies and brighter days return soon.